Hello students, in this video we are going to discuss about the chemical reactions of dihydrogen, that is H2. Chemical properties of hydrogen that depends upon the bond dissociation enthalpy. Usually hydrogen gas does not react with other chemicals at room temperature because the bond between the two hydrogen atom in hydrogen molecule is quite stronger. Because of the stronger bond, it is not easy to break the bond, therefore it does not react at room temperature. The reason for this bond to be a stronger bond, as when you compare the bond dissociation enthalpy for the other single bond, it is found that the HH bond dissociation enthalpy is the highest for a single bond between the two atoms of any element. So this bond is quite stronger, so it is difficult to break, therefore it requires very high amount of energy in order to break this bond. That means bond dissociation enthalpy is quite higher. That's why it does not react with the other chemicals at room temperature. So high amount of energy when it is given, then only it shows a reaction. So we can read out this sentence here. Hydrogen does not usually react with the other chemicals at room temperature because the bond between the hydrogen atom is very strong and can only be broken with a large amount of energy. That means high bond dissociation enthalpy. So it is one of the reasoning question that why hydrogen gas does not react with other chemicals at room temperature. So what is the reason? Because of a high bond dissociation enthalpy. So this is the reason. Because of this it does not react in the room temperature. Since it is orbital is incomplete with the 1s1 electronic configuration, so it does combine with almost all the element and it shows a reaction with most of the element because it have a incomplete electronic configuration, that is 1s1 electronic configuration. So it react either by the loss of electron, that means it form H positive, or it can react either by gaining the electron when it forms a negative charge here, and it can also form the compound with others by forming a covalent bond with it. That is, a single covalent bond is only possible with the hydrogen with other element. One of the example like methane. In methane, 4 hydrogen atom is bonded to a single carbon by a single covalent bond. So let us discuss different reactions of dihydrogen. That is, first we need to discuss the reaction with halogens, reaction with dioxygen, reaction with the dinitrogen, that is N2, reaction with metals, reaction with metal ions and oxides, and reaction with the organic compounds. So these reactions we have to discuss in detail. So first we are discussing the reaction with halogens. Halogens, we are generally representing the halogen as X2. So H2 plus X2. What is formed here? It forms halides. These are called as hydrogen halides. What is halide? When halogens have a negative charge, then it is called as halides. For example, chlorine. Chlorine, when it have a single negative charge, then it is called as chloride. Fluorine, when have a negative charge, then it is called as fluoride. So here hydrogen halides are formed. That means if here the reaction is between H2 plus Cl2, so what we can write the product here, HX is formed. It is generally represented HX. So what will be the particle product here? When it is react with chlorine, so it forms twice HCl. Twice HCl, that is called as hydrogen chloride. This is called as hydrogen chloride, which is commonly called as hydrochloric acid. So this is the reaction with halogens. Similarly, the reaction can take place with bromine, iodine, etc. Next is the reaction with the dioxygen. Dioxygen means O2. The reaction of hydrogen with oxygen in the presence of a catalyst or by heating this reaction, it is giving rise to the formation of product, that is water, and this reaction is exothermic reaction. Therefore the enthalpy change here, it is negative. It is a which type of reaction? It is an exothermic reaction. So the formation of water is taking place when the hydrogen is reacted with the oxygen to form water. Next is the reaction with the dinitrogen. Dinitrogen means N2. The reaction of hydrogen with the nitrogen at the temperature 673 Kelvin at 200 atm pressure in the presence of catalyst, there is a formation of a gas which is called as ammonia. This reaction is also exothermic, therefore the delta H value is negative. This is one of the most important method of manufacture of ammonia, and this process is called as Haber process. It is important. What is Haber process? The reaction of hydrogen with nitrogen in the presence of catalyst, it is giving rise to the ammonia. This process of manufacture of ammonia is called as Haber process. Next is the reaction with metals. With many metals, it combines at a high temperature to yield the corresponding hydrides. When it reacts with the metals, which is generally represented here as M. Here the example is, you can write the example. Here M is the alkali metal. For example, when we take a metal, that is a hydrogen plus the metal, that is M, we can take a metal like sodium. So what we get the product, we will get the product NaH, that is called a sodium hydride. So here the general equation is written here, and the particular equation is sodium hydride NaH when it react with sodium. So here there is a formation of metal hydride. This is called as metal hydride. How we write the general representation for metal hydride, that is MH, where M is the alkali metal. But when the metal is an alkaline earth metal, then the formula will not be MH, then the formula will be MH2, because for alkaline earth metal, what is the charge on it? The oxidation state is 2 positive and H having 1 negative. As I told already, in metal hydrides, hydrogen develops a negative oxidation state. Next is the reaction with metal ions and metal oxides. It reduces some metal ions in the aqueous solution and the oxides of metals, that is less reactive than the ion, into corresponding metals. That means the hydrogen can reduces the metal ions in the aqueous solution, that you can see here hydrogen, it reduces the lead ion into lead. So here what is actually happening here, the reaction is the redox reaction. So the hydrogen reduces the some metal ions in the aqueous solution and also the oxides of metal, as it is general representation is given here. It also reduces the metal oxides into metals. So what is the role of hydrogen here? That is when you look at here, the reaction PD2 plus is converted into PD. So what is the reaction here? The oxidation state from reactant to the product side, it is decreasing. That means a reduction is taking place. So what is the role of hydrogen here? Hydrogen is acting as a reducing agent here. So that is one of the important point for the hydrogen, that it acts as a reducing agent. That means it reduces the metal ions into metal and also it reduces the metal oxides into corresponding metals. So it is also one of the important point that it can reduces the metal ions into metal that you can see here metal ion is reduced into metal, and it also reduces the metal oxides into the corresponding metals. Next important reaction for hydrogen is with organic compounds. Organic compounds, that is compound usually made of carbon, hydrogen and oxygen. The first reaction is hydrogenation of vegetable oils. Using the nickel as a catalyst, it gives edible fats. That is the vanaspati ghee. Vanaspati ghee, that means the dalda which we are using at home, that is actually formed by the hydrogenation of vegetable oil. That is vegetable oil, as we know that vegetable oil is liquid in nature. That means in the room temperature it is liquid, and when we do hydrogenation means addition of hydrogen, and that is in the presence of catalyst like nickel. So what it formed, it form fats, that is it forms the fats here. So the fats are formed, that is the vanaspati ghee is formed, that is by the hydrogenation. That means the addition of hydrogen with a vegetable oil in the presence of catalyst nickel, and at the particular temperature it gives rise to a solid form. This is a solid form, and this one is liquid. So liquid we can convert into the solid form, that is by hydrogenation of a vegetable oil into the vanaspati ghee. This is one of the important reaction also. And hydroformylation of olefins yields aldehydes with further undergo the reduction to give alcohols. So this is also different reactions of organic in which the role of hydrogen is important here. For example, here the hydrogen with the carbon monoxide and with alkene is giving rise to aldehyde. So aldehyde formation is taking place, and in the second reaction also you can see the formation of alcohol taking place. That is a reduction of aldehyde into alcohol by using hydrogen. So these are the some of the important organic reactions for the hydrogen. And in the organic chemistry we will be discussing much more examples where the hydrogen is used for the different reactions. So this is all about the different chemical reactions of dihydrogen that we have discussed in this video. So this is all about this video. Have a nice day.